All right, so we are doing chapter 3, section 1B, second day. We're graphing polynomial functions. I want to recap the end behavior because I want to make sure that you guys got, if you look at a polynomial, do you know the basic shape of it? And do you know if it's going upward, downward? So here we go. Right here, starting here, I guess I'll number them 1, 2, 3, 4. All right, check it out. This is a positive, leading coefficient is positive, and it is an odd degree, cubic. So that means that it's going to look like this. Something like that. Here's x, here's f of x, which is y. Now, notice that this is written backwards from what we're used to. F of x, y approaches what as x approaches positive infinity? But last lesson, we had the x first. As x goes up to the positive, to the right, what's y doing? So you just look at the end behavior. As x is going more to the right, y is going up towards positive infinity, right? Or correct? Now I'm going to kind of reverse it and look at the end. As x approaches negative infinity, as x goes more left, 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 my y goes down, down, down. Right? So that's basically what we're doing. We're just recapping these. There's 4 of them, okay? Negative x to the 4th. My leading coefficient is negative, and my degree is quartic. Q-U-A-R-T-I-C, quartic. Here's what it looks like. If it's a negative leading coefficient and both end behaviors are going down, then it's going to be like this. Okay. 4th degree. So as x goes to the right, my y is going down. As x goes to the right, my y value goes down. See? X value, y value. Down and to the right. Here, left and down. Left and down. Negative infinity. This is just a refresher. Hopefully you're like, oh yeah, I got it. And I actually want my face to be bigger. Why not, right? Number 3, here we go. Oh, leading coefficient is negative. My degree is quintic. It's like something like that. Okay.
Ms. Grant?
Yeah.
Which set of notes is this on?
This was 3.1 from Tuesday. And this is probably page 3 or so. Page 3. As x goes right, my y goes downward. As x goes left, my y goes up, positive infinity. And you can just see, like, look, my x value is going to the right, my y value is going down. over on the left side, if my x value goes left, 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 my y value is going up, 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 up. Fourth one. My leading coefficient is positive. My degree is quadratic. It's just a parabola, guys. As x goes more to the right, my y actually goes up. Likewise, as my x goes more to the left on this side, my y still goes up. Okay. All right. So that's that for that page, guys. And remember, this is being recorded, so you can go on YouTube probably within an hour of class and it'll be up. Okay, I gotta turn the page, I gotta move on. Okay, I am going to graph using a table of values with you. I usually am not gonna ask you to graph a polynomial that looks like this. You know, if this is factorable, easily factorable, it's really hard to graph. If I don't know where my x-intercepts are and I'm not able to find a GCF or factor it, then I get to use Desmos. And we're gonna use Desmos today. So that's really good, right? So I'm gonna practice making a table of values because occasionally it might help to get a little more specific. You know, if you need to know, well, where is it in between 0 and 1, for example. So I'm gonna make my table of values quite spacious because I want to fit in my function x to the 5th plus 12x squared plus 9x plus 1. So it's like, well, what number should I pick for x? That's always a question students ask. What should I pick for x? I think you should pick small numbers always, a little negative and a little positive. So I'm going to do -2, -1, 0, and 1. I want to see on the left side of the y-axis and I want to see on the right side of the y-axis. Okay. So here we go. Just plug in, okay? I'm gonna just work on it and power through it because I'm assuming that you would do the same as far as your mathematical solutions would be the same as mine. Okay, well, -2 to the 5th is -32. 12 times 4 is 48. 9 times -2 is -18 plus 1. So if you can't keep up with notes right now because you're too busy trying to fill in this table of values, stop filling in the table of values. Just watch me. I don't want you to get behind in notes because you can't write or you're listening and you're hearing me say numbers and you're writing and then you're looking up and you're right. Just write the final answer. 16 plus -18 plus 1. Anyways, it ends up being -1. -2, -1. And plot that point. Now remember, this is a positive leading coefficient and it's a odd degree, so it's going to look like this. Here's the end of it, here's the right side of it. When I plug in -1, sorry, I got -1 to the 5th plus 12 times -1 squared plus 9 times -1 plus 1. Anyways, -1 plus 12 minus 9 plus 1 ends up being 3. Negative 1, 3. Now here's the deal. I don't know where my x-intercepts are. So I really can't make my graph look perfect unless I actually go on Desmos. Okay? So funny. Thank you, sir. 0. A lot of the times when you plug in 0, the answer is usually the last number, is 1. 0 to the 5th, plus 12 times 0, plus 9 times 0, plus 1. 1. And when I plug in 1, just so you know, oh, let me graph that. 0, 1. Graph it. Now I'm not going to connect the lines yet. Don't yet. And I'll explain why. When I plug in 1, 1 to the 5th plus 12 times 1 squared plus 9 times 1, it's 23. Which, I mean, that's so far away. It's like way up here. Now, here's what I'm going to do. I don't know where my graph turns and curves. It kind of looks like this right here. Might be. Here's a maximum. It's called a maximum. It's also called a turning point. But let me go on Desmos. I have it all ready for you. Hold on. Yes. Woohoo. Okay, ready? X to the 5th plus 12x squared plus 9x plus 1. Oh my goodness, check it out. Check it out. Okay. Ah. Okay. That point right there, that's my max. What is it? There it is. That's my maximum because that's the highest point that I can see. Also, look, you guys, it goes down right here and I didn't even know that. That's my minimum. It's like negative 0.3, negative 0.7. Jeez. Okay. Anyways, it's like a point right there. Oh, you can't see. Okay. This right here is my minimum, my lowest point, and it's also a turning point where my graph turns. So I'm going to follow now. Okay, here we go. Starting from low, dip, whoa, whoa, whoa. Dip way down and go up. Okay, so that's approximately what it looks like. And I did my best, what I could with the table of values, but then I had to look at Desmos to get like some specifics. I would never have known that this minimum right here was there, existed, if I didn't do Desmos. So Desmos is important because some of these we can't factor. So what I just did for you is I did an example using a table of values, us graphing it. And this would come in handy. It's like, well, what's in between like 0 and 1? What's 0.5? What if I really wanted to know 0.5 and I didn't have a graphing tool? Then I'd have to plug it in. Okay. You guys are lucky. You have this website called Desmos that I never had. So we had graphing calculators. Okay. So now I'm going to leave this. I'll pause the video because I want you to get your notes that I posted today called 3.1b. So I'm going to pause real quick. So here are our notes for 3.1b. And there's a couple of key words that we need to be introduced to. I kind of mentioned already the word turning points. Where does the graph switch directions? Okay, we call that a maximum or a local maximum or a relative maximum. This is higher than any other nearby point. It's a high point where it turns. There's also a minimum or a relative minimum, and that's a dip. That's the lowest point that we see. Okay. And a turning point, it's like, well, how do we know how many times the graph turns? Well, you look at the exponent, Okay. So you look at the exponent. And the max, like, what if I had like a y equals x to the 7th plus x to the 5th? Well, the maximum number of turning points, the most it could turn is my exponent minus 1. My n minus 1. My exponent degree, exponent n, take away 1. And that's if it's an even function. It's also if it's an odd function. That's the most turns it could have. Okay, now the least number of turns that it could have is going to be like if it's even, think about the smallest even degree. Second squared. So x squared looks like this. How many turning points does this, the minimum, the least I can think of is a parabola. How many turning points does this have right here?
1.
1. So on an even degree, it's 1, and that would be if it were a parabola. If it's to the 4th power, we don't know. If it's to the 6th power, we don't know. So that's for an even degree. That's the smallest I can think of, the second. An odd degree is like x to the 1st. That's the smallest exponent I can think of that's odd. 3 is still too big. Power of 1 is small. Well, you guys, an x to the 1st power, that's linear. That's just a straight line. So, since it's a straight line, it has how many turning points does this straight line have? How many turning points does a line have? We were saying none. It doesn't turn at all. It's a straight line. That would be linear. Okay, so this turning points idea. If I look at the exponent, I can say, well, I know that it's going to turn at least like at most 6 turning points at most for this one. Right? Because it's to the 7th degree. But, you know, every degree is going to be different. So that's the turning points. Turning points is also where's the highest, the maximum. Where's the lowest, the minimum. All right, the word multiplicity. The word multiplicity is me talking about crossing the x-axis, or perhaps just touching the x-axis. Where and how many times? Okay, so sorry, I'm gonna have like here we go. Check this out. If it has a degree of 1, okay, that's an odd degree, right? The degree of each factor indicates how the graph will behave at the x-intercept. So my graph is going to cross the x-axis. How many times? That's what this is. And is it going to cross over? Or there's another option. It could cross, it could bounce off of it, like just touch it. Okay, so bounce is also like touch, just touching, and then it flips back up again. So like a straight line, y equals x plus 3, that would just cross once. If it has a degree of 2, that's an even degree. An even degree bounces or touches. So that'd be like, like, boop. Oh, it didn't even touch. Right there. It just touches once. Okay. If I have a degree of like a 3, a 5, a 7, or 9, it could flex Flex means like a bend, but it could also cross. So I want to put this into practice, okay? Multiplicity. How many times and where does my line cross or bounce off or touch or, okay? So let's look at this. This is factored already. Yes? This is nice because we know that when I have an x minus 2 here, that means that I go x minus 2 equals 0 and an x-intercept is at positive 2, right? This x minus 2 is to the degree of 1 because it doesn't have an exponent, so it's a first degree. So I've got a 1 degree, which is a cross. So it's going to cross at 2. Cross at 2. These are all important right here. Okay. Let's make sure that it crosses at 2. Look at the graph. At 2, here it is. It crossed. Good. This x plus 1 squared means x plus 1, x plus 1. Factor it, solve for 0. X equals negative 1. That's one of my x-intercepts, negative 1. Is it crossing or is it bouncing? Look, here's a exponent of 2. That's an even degree. An even degree bounces, touches. It's going to bounce at negative 1. So I'm going to go to negative 1 and look at it. Negative 1, bounce. And obviously, you guys, I hope you understand this red line goes up, 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 up higher than the window, higher than my printing window, okay? This is all one line, but it just like goes up super high and this meets like way up there. Here, this is a power of 3, an odd power. An odd power is a flex or a cross. So right now at 3, x minus 3 equals 0. Solve. My x-intercept is at 3. My x-intercept is right here. And that is a flex. You can't see how it kind of like bends a little bit or cross. And it crosses over too. So I had like a little like bendy in there too. So I found my x-intercepts by setting each parentheses equal to 0. And then I was able to tell by the exponent of my parentheses, does it cross? Does it bounce? That's what multiplicity is. It's best if my polynomial is in factored form with the parentheses. If it's not, then you try and factor it yourself. If you can't, then you use Desmos. Okay. All right, let's move on. I'm going to go over some basics. Here's what I got. Domain and range. Okay. If it's an even degree function, then my domain is going to be, because you know, even degree means it's a squared or to the 4th power to the 6th power. I'm going to have a domain of all real numbers, but my range is going to depend on where my minimum or maximum is. Where's my high point? Where's my low point? That's what my range comes into play. So this K comes from like, if it has a vertex of HK, the K could be a high point if it's a negative function. The K could be a minimum, a low point if it's a positive function. So an odd degree now, all real numbers. Domain and range, all real numbers. Okay. Where does it increase and decrease? Where do I see my graph actually moving upward? Where do I see my graph moving downward? And that is what we did prior to this lesson. Look at this red graph that I have here. Look at this point. I don't know how to like, oh my gosh. Now I just figured it out. Okay. Be careful with my mouse, like right here. See that? That is a turning point. That's where it starts to decrease. So let's talk about decreasing. It starts to decrease right here and it goes down, 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 down to here. So I would write that as an interval from negative 1.5 to negative 0.3. That would be my decreasing interval. So you write it in interval notation, just like we had before. Increases, this one on the screen increases in 2 places. Okay. If I'm ever asked to find the zeros, which are the x-intercepts, which are the solutions, which are the roots, I set y equal to 0 and I try and factor it. Okay, remember, there's GCF that you could use. You could take out like a common x or something or a number. You could factor it with parentheses. All those difference of 2 squares, perfect square trinomial, there's all the ways. So now we're going to do a Desmos practice. It's right here. I'm going to graph this one, and we're going to talk about the maximum, the minimum, increasing and decreasing, because it's that important. All right, x to the third. So let's make it minus 6x squared plus 7x plus 2. Okay, here we go. Now, the relative maximum, the high point. Where does my graph like top out? The high point, turning point, right? Come on, mouse. There. Okay, here we go. 0.7, 4.3. 0.7, let's do it in a color. 4.3. Okay. My minimum, where's my low turning point? Turning point right here. 3.29, guys, just make it 3.3, that's fine. And negative 4.3. This is my minimum. These are both turning points. Maximum, relative maximum turning point. Relative minimum turning point. Now I care about where it increases. Where does it go upward? Upward starts way down here where I can't even see it from negative infinity. From negative infinity to there. 0.7. And then again, where does it increase? Starts way down here, 3.3. And it up, forever to infinity. Okay. Where does this decrease? Well, it only decreases in one spot. From here down to here. That's decreasing. 0.7 down to 3.2. Oh, you can't see that. I'm sorry. Okay, that's fine. Questions? You guys, questions? What questions do you have?
Are we going to be using Desmos for our homework?
Uh-huh. I'm going to teach you to find some things without Desmos, but you need to verify your graph with Desmos.
Why is it 3.2?
I don't know, 3.3. 3.29, 3.3. It was 3.3. Okay. I'm going to have you do this one on your own, this homework part, because you know how to do the end behavior by now. Looking at a polynomial, figuring out the end behavior. You're going to do that one on your own for homework tonight. Because I want to go and I want to show you one of your 4 homework problems. So, okay, here we go. Each graph, I'm going to either try to first factor it. Maybe I can do GCF. I got to try. Because like, look, number 2, I can do that. That's a difference of 2 squares. Number 3, I can factor out a negative x. Number 4 is already factored for me. That's really nice. My x-intercepts are easy to find. So let's go through my A, B, C, D, E together. Where does my graph increase? Now, I don't know anything about this graph. I haven't even done Desmos on it yet. X to the 5th plus 2. I have to think, can I factor this? Okay, let's do what we can without Desmos. You know what we can do? Find a turning point. Set x equal to 0. 0, x squared plus 5. 0 squared plus 2. I'm sorry, x squared plus 2. So look at this, x squared plus 2. That means when x is 0, y is 2. I know that. That's point. Yay. I might have another turning point, but I wouldn't know because right now I just got one option. Now I do know that this is a positive leading coefficient and it's an odd degree. That means it's going to look like this. Okay. You know what I can do? I can do D. I can find my x-intercepts. My x-intercepts means that I make y equal to 0. So 0 equals x to the 5th plus 2. Solve for x. I can do that one without Desmos. Subtract 2. And you're probably like, what the heck, x to the 5th? You guys, to solve for x, you do the, like, we usually, if it were x squared, we would take the square root of both sides. You do the inverse, the opposite root. I'm going to take the 5th root. I'm going to take the 5th root, and I have done it already on the calculator, so don't worry about it being a weird number. It is x equals the 5th root of negative 2. Well, guys, that's negative 1.1. So D is going to be negative 1.1 was my x solution, comma, I put 0 in for y, remember? I put 0 in for y. So I can graph that point. So I did, that's small. So I did what I could for now. On my end behavior, I knew because of my arrows, right? As x approaches infinity, f of x approaches infinity. As x goes up, y goes up. As x approaches negative infinity, f of x approaches negative infinity. As x goes down, y goes down. I knew that. So I don't know a and b. Okay? Where does it increase and where does it decrease? I need to do Desmos now. So this is just number 1 from your homework, okay? Let's x to the 5th plus 2. 5th plus 2. Ah, there's only one bend. The multiplicity, my crosses at negative 1.1, right? And that's it. So draw it. And I got a little bendy here at the y-intercept, right? You guys, this graph increased. So now I'm going to look at my part A and part B. Where does it increase? Where does it decrease? And wow, I'm going to teach all the way till the bell, guys. It increases the whole time. It's constantly going upward. That's all numbers. Negative infinity to positive infinity.
Miss Grant,
Yeah.
I have a question. How do you know like where to start the line? Because like we solved for the bend point, which is y equals 2, but then how do you know start the graph and like or the point?
I knew because it had a leading coefficient of positive and the degree was odd. Remember how we just spent all of Tuesday talking about what does it look like if I know these two pieces of information? I knew it looked like this.
So is it just, are you just eyeballing it or like?
No, I had to actually go to Desmos to get it exactly it.
Oh.
I knew it passed through 0,2 and I knew that the x-intercept was negative 1.1, but I didn't know anything else.
Okay.
So that's when you go to Desmos.
Okay.
This is not factorable. X to the 5th plus 2. Number 2 is going to be factorable. That's a difference of two squares. X squared plus 2, x squared minus 2. So you can like set that equal to 0 to find your x-intercepts, right?
Yeah.
You can plug in 0 for x to find your turning point. So number 2 is nicer because it's actually factorable. Real quick, back to this. My increasing was at negative infinity, like all real numbers, but it never decreases. This shape never decreases, none. So your job is to do A, B, C, D for, oh, people got kicked out. Your job is to do A, B, C, D for all number 2, number 3, and number 4. Number 4 is nice because it's already factored, right? You can tell what your x-intercepts are going to be. Number 3, there's a GCF. Negative x. So I set those both equal to 0 and I can find my x-intercepts, right? Which is the same as asking D, you know, what's my any zeros x-intercepts. So your job tonight for homework is this 2, 3, and 4, and then the ABC here, ABC, remember? That's your task. Try and do what you can with that, Desmos, and then use Desmos at the end. Yes. Yeah.
My audio is not that good right now. Like I got kicked out a few times before. Could you post? Is there going to be like an assignment posted on Google Classroom?
An assignment?
Mm-hmm.
No. I mean, I'm telling you, your homework is this: A, B, and C, and then I want you to do 2, 3, and 4. That's your homework.
Okay.
But this video is also going to be on YouTube.
Okay.
Give me an hour.
Thank you.
Okay. So I'm stopping.